Hello students, in this video we will be discussing the trigonometric ratios of angle exceeding 90 degree. Now see how you will see and how you will define such ratios, that is trigonometric ratios exceeding 90 degree. In junior classes we have studied trigonometric ratios in right angle triangle. If you have a right angle triangle like this, if this angle is theta, so if ABC is the right angle triangle, and suppose this is perpendicular, this is base, this is hypotenuse, then we have studied that sine theta is nothing but opposite side, that is perpendicular, by hypotenuse, and the cos theta is adjacent side, that is base by hypotenuse. Now how will be defining if the angle is exceeding 90 degree? Now for this, consider the coordinate system. Suppose this is your coordinate plane, this is O origin, and this is y-axis and x-axis. Now for the same, suppose my initial ray is OA. Suppose this is rotated through an angle theta to obtain this terminal ray. So this is the terminal ray and OA is initial ray to obtain. Suppose there is a point P on this terminal ray having coordinate of this point, say x comma y, and distance of this point from the origin is r unit. Now in this right angle triangle, that is OPL, this is x and this is y. So in this triangle, how will we define sine theta? Sine theta is nothing but opposite side, that is y, upon hypotenuse, that is r, and cos theta is x upon r. Now from this definition, x is equals to r cos theta and y is equals to r sine theta. Suppose if I take, say, another point on this ray, now how many points I can take on this ray? There are infinitely many points. Suppose there is another point, say p dash, on this ray having coordinate x dash and y dash. Now again, if I drop a perpendicular here, say suppose this is OPM, and suppose now this distance is r dash. Now again, in this right angle triangle, how will you define sine theta? Now sine theta will be equal to y dash by r dash. Now cos theta is x dash by r dash. Now what we have obtained from here, that is again the coordinate of the point, that is x dash, is r dash cos theta and y dash is r dash sine theta. Now what we are concluding from this definition is nothing new. We are just using the old version of the definition, but we are going to modify this definition. Now any point on this ray, suppose if I extend this ray further, there is another point, say Q, and having coordinates, say alpha beta, and say OQ distance is, say, a unit. Then how will write the coordinate alpha and beta? Now if you see this is nothing but r is the distance of this particular point P from the origin, and then we take the cosine, that is alpha, that is abscissa, will be a times of cos theta, and beta is equals to a times of sine theta, that is distance of this point from the origin and the then corresponding angle. Now we'll use the same definition to get the coordinates. Suppose if I make another figure, suppose This is my initial ray, this is O, and this is my initial ray OA. Suppose this is rotated through an angle, say theta, like this, and there is a point P here, and distance from the origin is say R. Then how you will write the coordinate of this point? The coordinate of this point will be simply R cos theta comma R sin theta. Now similarly, suppose if there is another point say here, and suppose this initial ray is rotated through an angle say theta 1, and there is a point say Q having coordinates say alpha and beta. Definitely alpha and beta will be negative here, but what is the coordinate of this? And suppose the distance of this point is R1, then the coordinate of this point will be R1 cos theta 1 comma R1 sin theta 1. So we'll make use of the same definition, and now let us generalize this definition, and we'll be getting the quadrant rule by using this definition. Now for instance, I'm considering one situation. Suppose there is a point in the second quadrant whose coordinates are minus 12 comma 5, and suppose inclined at an angle of 135 degree. The coordinates are say minus x comma y. Okay, and distance of this point is say this is P from the origin is say 1 unit. Then what will be the coordinate of this point? Your x coordinate will be simply minus cos 135 degree comma sine 135 degree, because distance is 1 unit. Now how will compare this? Now we can compare it like this. Actual coordinate will be writing this way, cos 135 comma sine 135 degree. If we compare it with minus x comma y, so your x is minus cos 135 degree and y is equal to sine 135 degree, like this. Now suppose let us define this way. Suppose we have this point P on the ray, this is terminal ray, and this OA is initial ray, and suppose this angle is theta, and this distance is R. Then what is the coordinate of this point? This is R cos theta comma R sin theta. Now if the actual coordinates are say x comma y, so then we define x comma y is equals to R cos theta comma R sin theta. Now from this definition we can say that my cos theta is x by R and sin theta is y by R. Now based on this definition, because now theta can be in this angle, terminal ray may be in the first quadrant, terminal ray may be in the second quadrant, and in the third quadrant or fourth quadrant. Now see, if I consider here quadrant and then sine of the cos theta, sin theta, tan theta, and we can write the sign of sec theta and cosec theta and cot theta. Suppose theta lies in first quadrant, that is first quadrant. So in first quadrant, you know that x is also positive and y is also positive, and since R is a distance which is always positive, so all this trigonometric ratio will be positive in first quadrant. In second quadrant, now if the terminal ray falls here, then definitely here in the second quadrant your x coordinate will be negative. So when x coordinate is negative, it means cos theta will be negative. If cos theta is negative, definitely tan theta is negative. Since y is positive, so sin theta is positive, and sec theta is negative, cosec theta will be positive because the reciprocal of sin theta and cot theta will be negative. And if it is of third quadrant, you know that if the terminal ray falls in the third quadrant, then both the coordinate x and y both are negative. So what we are getting from here, so cos theta will be negative, sin theta will be negative, tan theta will be positive because ratio of two negative things is positive, sec theta will be negative, cosec theta will be negative, cot theta will be positive. Now if it is of fourth quadrant, then what will happen? In fourth quadrant, if the terminal ray falls here, then definitely x will be positive and y will be negative. So we can say that cos theta is positive, sin theta is negative, tan theta negative, sec theta positive, cosec theta is also negative, and cot theta is also negative. So on the basis of this definition, we have derived the quadrant rule. So it is easy to remember this quadrant rule. This quadrant rule can be remembered by simply by using this quotation, that is all silver teacups. I'm taking the first letter of this, A, S, T, C. A stand for all, and this is for first quadrant. For second quadrant, in second quadrant, sin theta and cosec theta are positive because the reciprocal of sin theta is cosec theta. In third quadrant, tan theta and cot theta are positive, and in fourth quadrant, cos theta and sec theta are positive. So by using this concept, that is the trigonometric ratios exceeding 90 degree, so we have derived the quadrant rule. So I hope students, you have understood the concept of quadrant rule and the trigonometric ratios exceeding 90 degree. So in the next video, uh, we'll be uploading the content regarding the reference angle, and by using this quadrant rule, I will find the trigonometric values of ratios exceeding 90 degree. Thank you for watching it.